Hi there, this is lesson 2 of Unit A, and today the lesson is called Classification of Matter. So on the last video we talked about what the definition of chemistry was, what the definition of matter was, and the phases of matter, and even some of the different areas that chemistry was involved in. Now on this episode we are going to cover classification of matter, types of mixtures, and the differences between elements, mixtures, and compounds. So this flowchart is the best flowchart there is to talk about matter, and it breaks it down, but it also has us ask a few questions about what we're looking at. The first question is, can it be physically separated? So I'm going to go into what all this stuff means later on, so let's just fill out this chart together. So can it be physically separated? If we answer yes, we have a mixture. So physically separated means you can just kind of take it apart pretty easily. Things you've done already. So like using a filter and stuff like that. So if it can be physically separated, it is a mixture. Now we have to look at the composition of that mixture. If the composition is uniform, we call that homogeneous. And if the composition is not uniform, we call that heterogeneous. Again, we're going to go into all this in more detail shortly. So if we go back up to the top and ask ourselves, let's go on the other side of the flowchart, can the piece of matter be separated physically? If we answer no, that means it is a pure substance. And then if that pure substance can be chemically decomposed, if the answer is yes, it's a compound. And if the answer is no, it is an element. So basically when we're looking at matter, we're saying, is it made of multiple stuff or is it one type of thing? So you can say this is many things and this is one thing. Now, if you can see the different things in the mixture, homogeneous. If you have different amounts of things in the mixture, it is heterogeneous. And then back to here, if you have one thing and that one thing can be broken down, it is a compound. If that one thing cannot be broken down, it is an element. Okay. So jumping into mixtures, mixtures are two or more things in the same place at the same time, not chemically combined. So that's super important. Compositions may vary. So here is a picture of trail mix. It looks like there's some M&Ms, some raisins, some almonds, some cashews, stuff like that. But if you get a different brand of trail mix, it may have a different amount of nuts in it, may have different candies in it. So just because it's trail mix doesn't necessarily mean it's going to be the same every single time. Mixtures are physically combined and can be physically separated. And so what physically separated means is we're not using chemical reactions or these properties. Again, things we will get into shortly. So examples of physically separating stuff is evaporating and boiling stuff, literally picking it out, using filter paper, and more. So if I wanted to separate the M&Ms out of this trail mix, I can literally just pick up the M&Ms and separate my mixture. Now, the composition of mixtures plays a big part, and that tells you if it's a heterogeneous mixture or a homogeneous mixture. So if the composition is uniform, or in other words, uniform is the same throughout, it's homogeneous. So if you look over here, our homogeneous mixture, every sample is basically the same. It's very organized and it's pretty much uniform. If the composition is not uniform, it's kind of like all scattered in a mess, that's heterogeneous, and that's what this picture is showing. So going into more detail on homogeneous mixtures, again, the composition is uniform. There are no visible differences. So you won't be able to really see the pieces that make up that mixture. And if you sample from two or more sections, the samples will be exactly the same. So in this picture, if I was to take two circles that are next to each other, those are next to each other, those are next to each other. No matter where I pick, I always get the same thing. And again, some examples of these are things dissolved in water, air, and there's so many more. So looking into heterogeneous mixtures, again, the composition is not uniform, and there are visible differences. So here you're able to visibly see the different pieces that make up that mixture. And if you sample from two different spots, the sections will be different. So if I randomly sample from there, I get just red objects. If I sample from down there, now I have blue objects. They're different. Examples heterogeneous mixtures could be a rock in a beaker and air if, let's say, it's polluted. If someone sprays perfume, in that right instant, it is not uniform. Okay, so question. Fruit salad, homogeneous or heterogeneous? So you should have picked heterogeneous because the composition is not uniform throughout. If I bite from here or bite from there, I get different things. Freshly squeezed lemonade, and I'll give you a hint, it looks pretty much the same throughout. So you should have picked homogeneous for this one. Again, everything looks like it's exactly the same. If I took a sip of lemonade up here, or if I took a sip down there, or in this cup, it should be exactly the same. If it's not, that's really bad lemonade. Okay, next one, oil and water. So this should be heterogeneous because you can obviously see the different layers. You have the oil layer on top, you have water on the bottom, and if I were to sample from those two sections, I would get different things. And one of the last examples is pancake batter. Now you should have said homogeneous because if you're stirring the batter well, you shouldn't have any chunks of flour or anything in there. Everything should be the same. Okay, so again, this is a super awesome classification of matter chart, and I hope this kind of makes more sense on this part. So let's jump into the other side. So a pure substance is something that cannot be separated down by physical means. So you can't just, put it in a filter and see what happens and separate the different things. So here is some salt. And one of the other categories of, or characteristics of a pure substance is that the composition is definite and constant. So here's salt, and this is NaCl. No matter where I put this salt, what I do to this salt, it is always going to be NaCl. And it will always be, your common table salt. And, and also known as, if you want to call it pure substance, you can also call it a chemical substance. So now jumping into compounds versus elements. Compounds are made up of two or more different elements, and they can be broken down through chemical reactions. So H2O, CO2, this one down here, is glucose or sugar. So compounds can be broken down and can form different compounds. But elements, on the other hand, those are the simplest substances. They cannot be broken down using chemical reactions. Elements is basically as simple as you can get. So, here's C stands for carbon. You can't split that carbon into break up into different things. It's literally just carbon. Okay. So here's another version of the flowchart. Again, we have our matter, pure substances, and mixtures. And then in our pure substances, we can have elements and compounds. And then here, these bottom drawings are called particle diagrams. So we're going to learn how to do those pretty shortly. Okay, so on the next time, we will cover particle diagrams, what they are, and how to draw them. Bye.